All right, welcome back. Today, we're going to level up. We're moving beyond just asking an AI a simple question and diving headfirst into the world of professional prompt engineering. We're going to explore the strategy that turns any AI from a kind of useful tool into an absolutely robust, intelligent system.
I mean, it's a question we've all had, right? Why is it that one chatbot gives you this perfect, nuanced answer, while another one just completely misses the mark? Well, the answer, as you're about to see, isn't just about the AI model itself. It's all about the professional strategy used to feed it information.
And that, right there, is the secret sauce. The secret weapon behind any great AI application is a really well-defined content strategy. It's about consciously designing the information, the very fuel that powers every single one of its responses.
Okay, so let's jump right into the core strategy. We're going to break down the one big idea that truly separates the amateur prompts from professional-grade AI engineering.
A real professional prompt strategy? It all starts right here with this conscious separation. You don't just, chuck a wall of text at an AI and hope for the best. No, you deliberately divide your information into two very distinct categories, and each one has a critical job to do.
And this slide just lays it all out perfectly. Think about it like this. On one side, you've got your static content. This is like the AI's permanent operating manual, its rulebook that never, ever changes. And on the other side, you've got dynamic content, the live, specific facts about the current situation. Mastering this balance? Well, that's the whole game.
All right, first things first. Let's build that foundation by really mastering our static content. This is how you give your AI its core instructions, its personality, and most importantly, its unbreakable rules.
The whole point of static content is one thing: consistency. An AI without clear rules is just chaotic, right? It's unpredictable and, frankly, often useless. This rulebook is what gets rid of all that ambiguity and makes sure you get reliable, predictable results every single time.
Okay, so the most straightforward way to build this rulebook is with explicit instructions. But, and this is a big but, how you write them makes all the difference. First, formulate positively. Instead of saying, don't use plain text, you'd say, output everything as a markdown list. Second, justify your rules. Explain why a link can't be included. And finally, try to avoid absolutes. Saying, never refuse a request is just asking for trouble. Something like, only refuse in exceptional cases is way more robust.
And wow, this is a perfect real-world example. These are actual leaked rules from Microsoft's early Bing chat, which was codenamed Sydney. Look how specific this is. The AI is told exactly what to call itself, what its purpose is, and, critically, what not to reveal. These kinds of explicit rules define its entire persona and its behavior.
Now, the second method for building static content is a little more subtle. It's called few-shot prompting. A zero-shot prompt is just what it sounds like, a direct question. But a few-shot prompt is different. You actually show the AI a few examples of what you want before you ask your question. You're guiding it by demonstration, not just by instruction.
But you gotta be careful here. This method has a major pitfall, and it's called anchoring. The examples you provide create a bias. So if all your examples of book recommendations are from the 20th century, the AI is way more likely to get stuck in that era, even if a brand new book is a much better fit. Your examples can accidentally shrink its world.
And then there's the other danger, which is even sneakier: spurious correlations. See, LLMs are absolute masters at finding patterns. So if your 3 examples just so happen to be sorted by length, the AI might think, aha, that's a rule, and start following it. So, what's the big takeaway here? If you're using examples, always randomize their order to avoid creating these fake patterns. Okay, so our static foundation is solid. The AI knows its rules. Now for the fun part. Let's inject some real-time intelligence with dynamic content, the stuff that changes with every single query.
The way the pros do this, the industry-standard technique, is called Retrieval-Augmented Generation, or RAG for short. This is the magic sauce that lets a chatbot know about today's news or search through your private documents. It's how we give an LLM knowledge way beyond its original training data, and we can do it without having to retrain the whole massive model.
And you know what? The process itself is actually beautifully simple. It's just 3 steps. First, your system retrieves relevant little snippets of info from a knowledge base. Think of it like searching for key paragraphs in a user manual. Second, it augments the prompt by just adding these snippets right in.
And finally, the LLM generates an answer using this brand new context. That's it. That's pretty much how all modern knowledge-heavy AI applications work.
But here's a huge heads up with RAG. There's this critical pitfall we can call the Chekhov's gun fallacy. LLMs operate like a good storyteller. They assume every single detail you give them is important and absolutely must be used. And that means providing irrelevant information is actually worse than providing none at all, because the AI will try to force it into the answer and probably ruin the whole result.
So, the big question is, how do we make sure we're only finding the truly relevant stuff? Well, you've basically got two main paths you can go down. Lexical retrieval is simple keyword matching. It's fast, it's transparent, but it's pretty basic. Neural retrieval, on the other hand, is much smarter. It understands semantic meaning. It knows that car maintenance tips is related to how to fix an automobile, even if the words don't match exactly. It's way more powerful, but it's also more complex to set up and debug.
But what happens when this retrieval process works a little too well? I mean, what if you find an entire 300-page book that's relevant? You can't just cram that all into the AI's context window, but you can't just ignore it either.
The solution is this really clever divide-and-conquer strategy called hierarchical summarization. First, you divide that massive document into manageable chunks, like chapters. Then, you get the AI to create a summary of each individual chapter. Finally, you take all those chapter summaries and ask the AI to combine them into one final, high-level summary of the entire book. It's just a super elegant way to compress a vast amount of knowledge.
And just like that, we now have the two essential pillars for a truly professional prompt. We've got our stable foundation with static content, and we've got a way to pump in relevant, dynamic context when we need it.
But hang on, we're not quite finished yet. Just having all the right stuff isn't enough. It's kind of like having all the perfect ingredients for a cake just dumped randomly into a bowl. A messy, disorganized collection of instructions, examples, and facts is only going to confuse the model and give you really poor results.
And that leaves us with the next huge question, doesn't it? We have our ingredients, the static and the dynamic content, but how do we write the perfect recipe? How do we structure it all, arrange it, and prioritize it so that an AI can follow it flawlessly every single time? Well, that is the next step on the path to true prompt mastery.